Hello, and welcome to Backer Breaks It Down. In this episode, we are going to compare exponential and linear functions. So let's talk about linear functions, which we have studied before. In a linear function, the difference of consecutive y values is constant. In fact, we say that linear functions have a constant rate of change. When you look at a table of values, the pattern that you will observe is either addition or subtraction. The value of m in the linear function formula, y equals b plus mx, represents that number that you're adding or subtracting. M is positive for addition, it's negative for subtraction. And b is the initial value of the function. That's the value when x is 0. Exponential functions are functions in which the ratio of consecutive y values is constant. When you look at a table of values, the pattern that you see is multiplication or division. When you write an exponential function formula, it'll be of the form y equals a times b to the x power. B is that constant ratio. It is the number being multiplied. So if the pattern that you see is division, remember that division is multiplication by the reciprocal. And then a in the exponential function formula, y equals a times b to the x power. A is the initial value. It's the value when x is 0. So our first 3 examples will look at tables of value. We want to look at the pattern to determine is the table representing a linear function or an exponential function. Remember, if it's linear, the pattern that we will observe will be either addition or subtraction. If it's exponential, the pattern will be multiplication or division. Okay, so we're going to look for a pattern here, and that pattern will tell us whether the data represents a linear function or an exponential function. Once we identify the function, if it's linear, we're going to write an equation y equals mx plus b. And if it's exponential, we're going to write an equation y equals a times b to the x power. Feel free to pause here and try out these 3 problems and then check back in with me. Okay, so let's see how you did on problem number 1. So when I look at the pattern in my y values, I see that my y values are increasing by 4. So I am adding 4 each time. This indicates that table 1 is a linear function. That plus 4 is the value of m, my rate of change. The value of b is the initial value of the function, and in this one, that would be 3. So for my linear function, I'm going to write y equals, my m value is positive 4 times x plus my initial value, which is 3. In the second table, the pattern that I'm observing isn't obvious at first, but once I get into those whole numbers, I see that I'm multiplying by 4. Sorry about that. Don't know how that line happened. The bottom line here is multiplication by 4 indicates an exponential function. That multiplication by 4 is the value of b, because b is that change factor, the number I'm multiplying by. The value of a in my exponential function is the initial value, the value when x is equal to 0. So in this problem, that value is 2. So I'm going to write y equals 2 times my b value is 4, and I'm going to raise that to the x power. Finally, in number 3, the pattern that I observe at least, is division by 3. That's the pattern that I see, okay? Which means that this is an exponential function, okay? But 3 is not the value of b, because b is the number I'm multiplying by. Instead, b is the reciprocal, so it's 1/3. Division by 3 is the same as multiplication by 1/3. That's the reciprocal. The initial value of my function is right here. When x is 0, y is 9. So for my exponential function, I'm going to write y equals 9 times 1/3 to the x power. And so here, these are the basics of linear versus exponential functions. Linear functions, the difference of the consecutive y values is constant. The pattern is addition and subtraction, and we can write linear functions of the form y equals mx plus b. Exponential functions have a constant ratio. The pattern that we see is multiplication or division, and we write exponential functions in the form y equals a times b to the x power. And that is how Becker breaks it down.